Welcome, Year 13 MAC. Today we are stretching your brain cells beyond what they are normally stretched with. How do I mean? Well, I mean is I'm going to teach you or show you how to integrate Trig products. Okay? Now, Trig products means that you've got two or more trigonometric things multiplying each other, but you can't integrate them unless you change them into trig sums or trig differences. And you'll find these on your formula sheet in the exam, but you must know how to use them and when to use them, okay? And I have put them all up on Teams, so you can look at them there. Now, I'm going to do something a bit silly, a bit stupid, because what I'm going to do is I'm just going to talk a little bit about this first example, but I'm not going to show you how to finish it off. The reason is it involves fractions and it gets a little bit hairy, okay, a bit more complicated than I wanted it to be for the first example. So what I'm going to do is we're just going to talk a little bit about the example here, the first example, but then I'm going to go to and do the second example. I'll show you that because it's easier. Okay, it's an easier one. And then I'm going to come back to example one and show you how to finish it off. Okay, but let's look at this first one just briefly and see what's what. Well, you're being asked to integrate this thing here. And this is a product of sine being multiplied, multiplying cosine. This is sine of 7x over 3. That is an angle. And this is the cosine of 2x over 3, which is a different angle. Okay. And when you've got sine multiplying cosine, you use this identity here to split it up. And you'll notice this 2 here. Well, this 2 gets cross multiplied into 1/2 times all of that. Okay, you're going to see that fairly soon. But anyway, when you have sine A multiplied by cos B, you can rewrite it with this identity as the sine of the sum of these angles, A and B, plus the sine of the difference of these angles, A and B. Okay? All right, now that's the way in which example one is going to start. I'm not going to get into it now because it's a bit tricky, but I am going to show you example two. So I've got to zoom out of this one, go to the second page and zoom into this one and do example two. But I will come back to example one when I've done this, okay? Now let's get this in the right place. There we are. Okay, now here's example two. It just says integrate cos 8x multiplied by sine 2x. 8x is a different angle to 2x, okay? So this time we've got cosine multiplying sine, cosine of A multiplying the sine of B, and in this case we use this identity here. Now notice the half here. This 2 is usually written over here, as I showed you before, but I've decided to put it there because I want that to look very much like this, okay? So how does it go? Well, it's a half multiplying all of that. Well, it's the sine of the sum of these two angles minus the sine of the difference of these two angles. Okay, now what does this look like in this particular question? Well, here we have the integral, and it's a half, and it's the integral of the entire thing here, which is the sum, the sine of the sum of those two angles. So it's 8x plus 2x. So that's going to give me the sine of 10x. And here it's minus the sine of the difference of these two angles, which is going to give me 6x there, sine of 6x. Now you can already see that it's becoming to look a little bit easier because we've now got just two relatively simple integrals to work out. this one sine of 6x, and this one the sine of 10x. Now, I have missed out a slight step here because I'm hoping that by now you can see what I am doing. What I'm doing is I'm letting u be 10x, and when I differentiate that, I get du by dx is 10, and then I can say that du is 10 dx. And remember, I'm multiplying the dx by 10 here, but I've got to divide by 10 at the same time to keep the integral the same value, because that's really just 1. Okay, and I'm doing the same thing here, but I'm not calling it u, I'm calling it v. I'm saying v equals 6x, so dv by dx is 6. So when I multiply 6 by dx, I have to divide by 6. Okay, and we said that the 6x was v, so it goes to v like that, and dv there. Of course, now this 6 on the bottom goes in front of the integral sign there, just as this 10 in the denominator goes in front of this integral sign as 1 over 10. Okay, now look what you're left with. You're left with something supremely easy. You've got the integral now of sine u du, and here you've got the integral of sine v dv. Okay, now when you'll notice that this is positive here, positive sine u. Now this sine u is the derivative of something. What is it from? It's from cosine. But you have to be careful, because when you differentiate cosine, you get minus sine. But this case, we've got plus sine. So in other words, that plus sine u, when integrated, is going to go back to minus cos u. And that minus I've multiplied out at the front there, because I've multiplied the 2 and the 10 to give me 1 over 20. But I put the minus sign out at the front. The same is true here. This is the derivative. Sine v is the derivative of not cos v, but minus cos v. And the minus, so when I integrate this, I'm going to get minus cos v, and the minus for the cos v would multiply out with this minus here to give you plus there. Okay, so the final answer is minus 1/20 cosine of 10u, because we said u was 10x. Sorry, not 10u, 10x, I mean. Cosine of 10x, because 10x is u, plus 1/12 the cosine of 6x, because 6x is the v after all. And at the bottom of the page here, I've just put a little reminder of, if you differentiate the cosine, its derivative is minus sine. So if you integrate positive sine, you must get negative cosine. If you integrated negative sine, it must go back to the positive cosine there. Okay, now let's go back to example 1 and see how that works. I'm just looking at my time. Yes, I've still got some time left. So if I go back to there, okay, let's zoom into this and see if we can get our heads around these rather ugly fractions. Okay, so how does it go? Yes, well, you're being asked to integrate this thing here. You're going to use this identity here, and I'm going to be doing the sine of the sum of those two angles plus the sine of the difference of those two angles. Okay, so it's very similar to the last one, but the only difficulty in this case is that we've got fractions involved and they look a bit nasty. Okay, so there's that 2 I talked about, and in this line here I've cross multiplied the 2 down below here, so it's the half of the sine of all of that thing there, a half of all of that there. Well, it's the the sine of the sum of the angles was 7x plus 7x over 3 plus 2x over 3 gives me 9x over 3. Don't forget, I can only add them like that if these denominators are the same. And here, when I go 7x over 3 minus 2x over 3, I get left with 5x over 3. So there it is. That's the thing I'm now going to integrate. So the integral becomes this fearsome looking thing here. If I just move it along like that, ran out of space at the sides, but anyway. So it's the integral of a half of sine of 9x over 3, which of course is going to be simplified to 3x, plus the sine of 5x over 3 there, dx. Well, this half here, which is a constant, I can put outside the integral sign here. And what am I left with? I've got to be a bit careful here because I'm now going to integrate this and I'm going to integrate this separately, which is why I've written two integral signs. The integral sign of the sine of 9x over 3 plus the integral sine x sine 5x over 3. But I have to be careful because this half multiplies all of that, which is why I've got these squiggly brackets there and there to show that all of this is going to be multiplied by a half. All right, now just watching my time, I've got 4 minutes left. So this becomes the integral of sine 3x dx plus the integral of the sine 5x over 3, like that. Now, again, I'm doing the same thing. I'm letting u equal 3x. So I'm going to be multiplying this dx by 3, but I'm going to divide by 3. Same here. When I differentiate v equaling 5x over 3, I'm going to get 5 over 3. And so I will write dv equals 5/3 dx. But I've got to divide by 5/3. This 5/3 on the bottom goes in front of the integral sign there. And this 3 goes in front of the integral sign there. I've got it in the bottom there. So what am I left with? I'm left with this much easier integration of sine u du and of sine v dv. Okay, now the rest of this is on the next page. Whoops, that's the wrong way. Silly me. Click that one, click that one. There it is. Yeah, so I'll just zoom into the top and we can finish this off. Okay, whoa. There it is. So when I integrate sine u du, I'm going to get minus cos u. And when I integrate sine v dv, I'm going to get minus cos v. That minus is going to make that plus go to minus. And this minus is going to stick out the front there. The half now multiplies everything inside, so that becomes now 1/6 times the cosine of 3x minus there's a mistake. Yes, that should be 3 over 10. You see that half? You see that half there? It should have multiplied the 5. See how easy it is to make a mistake if you don't put these brackets in. I made a mistake. So that should say 3 over 10, not 5, cosine of that. But don't forget the constant of integration. Okay, now I'm running out of time, and I will put this up on Teams as soon as I can with some examples for you to do. I think it's called example 20.04, and I'll put the answers up, so don't worry about it. Any problems, please post them onto Teams. Okay, goodbye.